Hello everyone, my name is Jingyu Zhang. I'm from Agnes Scott College. Today I will introduce you to my research project last semester, which is under the guidance of Dr. Gongjie Li and her graduate student Harish from Georgia Tech. The topic is about outer solar system dynamics. Specifically, I studied the effect of galacticTide on trans-Neptunian objects. So trans-Neptunian objects, which refers as TNOs, are any solar system minor planet that orbit the sun at a greater average distance than Neptune, the 30 AU semi-major axis distance. The most famous TNO we know is Pluto. In 2014, scientists predicted a hypothetical planet to exist far beyond Pluto, known as Planet 9. In this hypothesis, Planet 9 has a mass of 10 times greater than the mass of the Earth and has a semi-major axis about 300 AU to 700 AU. Here's a picture that indicates you the location of Planet 9. For studying dynamic features of TNOs, we also need to consider the factor of galactic tide, which is the topic of today. A galactic tidal force is a gravitational effect due to the shape of the galaxy. It influences more when the object gets closer to the galactic center. You can think of the scenario as a tug-of-war game. I made a doodle drawing here to help you quickly have a sense of what's going on. There are some simulated particles in the outer solar system experience the force from all ingredients. The Neptune, which is 30 AU away from the sun, the J2 term, the inner jet planet, Jupiter and Saturn, the hypothetical planet 9 perturber at around 300 to 700 AU, and lastly, the galactic tidal force. So you can see here in my picture, I draw some purple dots indicating the particles in the outer solar system, and the blue circle is Neptune, which is at 30 AU, and those two inner jet planets are Jupiter and Saturn, which known as J2 term in the simulation. And lastly, here I draw the galactic center, and here's our Milky Way. You can see that I also highlighted the forces name, which is the Neptune force, the J2 term, the galactic tidal force, and also there's a pink planet I marked as a question mark because we don't know where it's located, which is the hypothetical planet, Planet 9 perturber. So all of it created a dynamic environment for these particles in the outer solar system, kind of like a tug-of-war game, different forces to different directions that finalize where the location and the dynamic factors for these particles. In this case, our study uses 100 particles to simulate the dynamic environment that TNOs are experiencing. Again, TNOs refers as Trans-Neptunian Objects. We wanted to simulate many massless particles in the outer solar system so that we can choose to use the n-body simulation method to calculate the integration. In the integration simulation tool Mercury, we have a big perturber and 100 of small testing particles. During each simulation, we use different conditions, such as the perturber as only the Neptunian effect, or the perturber as J2 term and the galactic tidal force, or the perturber as galactic tidal force and the planet 9 effect. You can see that there are many combinations for those factors. Throughout those different trials of simulation, we plot each particles with 4 orbital elements versus the semi-major axis of those particles. The 4 orbital elements we examined are the eccentricity, known as little e, the inclination, little I, the longitude of ascending node, the bigger case, omega, and the argument of the pericenter, which is a smaller case, omega. Eccentricity and inclination describes the shape and the tilt of the ellipse planet respectively. The longitude of ascending node and the argument of pericenter depicts the precession and the orientation of the orbits. So we had a lot of graphs generated from this project, but due to the sake of time, I will show you on one of them. This figure shows us 100 testing particles with J2 term and the Neptune as a point mass. You can see the 4 orbital element versus the semi-major axis. So in a nutshell, the result shows us a few things. First, the point mass Neptune can affect the precession of the orbit. Second, J2 potential effect can change the direction of the orbit for the object. And third, we find that the galactic tidal force can increase the eccentricity and the inclinations of the orbit. Besides, both galactic tidal force and the planet 9 can lead to a clustering on orbital orientation, though with different properties. Different behaviors of clustering due to the galactic tidal force and planet 9 can help the scientists constrain the properties of planet 9. In the future, I will carry on more simulations. The significance of my work is that for studying the outer solar system and exoplanet, it's imperative to understand the dynamic property for the planet 9 and the effect of the galactic tidal force. In the near future, I will carry on my simulation for more data results. And thank you so much for Dr. Gongjie Li and Harish Gratham for advising me during the research online. Thank you.